Hi guys, today we are going to discuss ionic bonding. It's one of the topic in chemistry for secondary level. You might learn this from grade 7, 8, 9 or 10. So what is ionic bonding? First to remember, ionic bonding is between metals and non-metals. Here there is periodic table given to you to show which elements are metal. So this side is metal and the yellow sides are non-metals. So it's formed from element, one of these element in here with one of the element in the yellow section. Now let's see the example of ionic bond. We have sodium chloride is the most common ionic compound, NaCl. The metal is sodium. The metal is sodium, and sodium is in group 1. So the metal is taken from group 1. Sodium is in here. This sodium. Now, sodium is in group 1 and chloride is in group 7. This is chloride, is in group 7. Now we will discuss about ionic compound sodium chloride, NaCl. In here the metal is sodium or Na. It forms positive ion or cation. So there is a plus sign T in here, is similar to plus sign. It means cation is positive ion, T and T. How does sodium form positive ion? By losing one electron to become Na+. As we know, sodium is in group 1. All elements in group 1 has one electron in its outer shell. So it's easier for the metals in group 1 to lose one electron to gain stable configuration. Now, non-metal is Cl. As we discussed, it is from group 7. Cl is group 7, this one. And Cl is in group 7. It means it has 7 electrons in its outer shell. So it gained one electron to form Cl minus ion. And that is a negative ion, or we call as anion. In here it is display Na with one valence electron in its outer shell, and the one electron is transferred to Cl, which has 1, 2, 3, 4, 5, 6, 7, since Cl is in group 7. Now Cl received 1, so Cl now become 2, 4, 6, 8 electrons, and Na become Na plus, and also has 8 electrons in its outer shells. So first Na has 11 electrons. As it loses one electron, it becomes 10 electrons. Now the 10 is arranged in first layers 2, second layers 8. So now Na plus has 8 electrons in its outer shell, and Cl minus also has 8 electrons in its outer shell. The configuration of 8 electrons is the most stable one. Easy trick to remember. Sodium is in group 1, so it becomes +1. Cl is in group 7, so 8 minus 7 is 1, so it has charge of -1. So that's how we know Na is +1 and Cl is -1. So Na plus and Cl minus, they react to form ionic compound NaCl, and this is how they are arranged. And NaCl crystal, the Cl is here, and then Na plus is in here. So this is the structures of sodium chloride crystal. We go to next example is magnesium sulfide or MgS. In here the metal is of course magnesium, magnesium is in group 2. You see magnesium in group 2. Where is magnesium? It is here in group 2. And sulfide is in group 6. Acid sulfide in group 6. So if it's group 2, it means Mg will have the charge of positive 2 according to this group, and S will have the charge of 8 minus 6 is 2, so negative 2. So the metal magnesium from group 2 will form positive ion by losing 2 electrons, become Mg2 plus, and non-metal sulfide is from group 6. It will form negative ion or anion by gaining 2 electrons, become S2 minus. So Mg will donate 1 electron and 2. So 2 electron to sulfide, become Mg2 plus and S2 minus. They react to form magnesium sulfide. This is the structures of magnesium sulfide. Next example is magnesium chloride. Again, the metal is magnesium from group 2, so it formed a charge of 2 plus according to its group number. So the charge is 2 plus. While Cl is from group 7, so Cl from group 7, so how to count the charge is 8 minus 7 is 1, so Cl has the charge of negative 1. So we just write and only negative. Now, how is the bonding happen? Mg will donate 2 electrons, 1 to each Cl. So 1 to the left, 1 to the right. And this is a diagram. Mg transferred to Cl. 1 electron to Cl, another electron to the other Cl, and become Mg2 plus and 2 Cl minus. Well, the question is, why don't they form MgCl? Why they have to form MgCl2? The answer is Mg has a charge of 2 plus and Cl has a charge of minus 1. So the net charge of MgCl is not equals to 0. The net charge of the ionic compound has to be 0. So we need to put Cl, 2Cl. Since Mg will have the charge of 2 plus and Cl will have the charge of minus 1, so to balance the 2 plus, it needs another minus 1. So that's why we get MgCl2. MgCl2. So this becomes MgCl2. Or another way to form the ionic compound is you write the metal element Mg2 plus and Cl is the non-metal minus 1. And the charge will exchange. 1 go to Mg and 2 go to Cl. So Mg only 1, so only Mg and Cl get the 2 from here. So Cl2. And this is a neutral compound. We see that ions Mg2 plus and Cl minus, they are linked together by electrostatic forces of attraction, since positive and negative ion attract one another and a bond is formed between them, which is called ionic bond. And this is what the structures of MgCl2 look like. There we go. So let's sum up all about ionic bond. Alright, summary. Metals in group 1, 2, 3 form positive ion by losing electron, and non-metals in group 5, 6, 7 form negative ion by gaining electrons. So for all metals in group 1, the charge is plus 1. All metal in group 2, the charge is group 2. All metal in group 3, the charge is positive 3. For all element here, Li, Na, K, they all have the charge of positive 1. And for group 2, Mg, Ca, they all have the charge of positive 3 and positive 2. So group 2 is the charge is positive 2, and in group 3 is like Al. This is group 3. You will have the charge of positive 3. While for non-metal in here, for group 7, we start from group 7, FClBri. It has the charge of negative 1 since 8 minus 7 is 1. For all the non-metal in group 6, OSSE, it will have the charge of negative 2 since 8 minus 6 is 2. And for all the elements or non-metals in group 5, the charge is negative 3 since 8 minus 5 is 3. Next point, ionic compounds consist of a giant structures of ions, like this one, MgCl2, or this one, magnesium sulfide, or this one, sodium chloride compound. Next point, they are held together by strong electrostatic forces of attraction between positive and negative ions, or positive and negative we can say as oppositely charged ions, as we know. Positive and negative or opposite ion attract one another. That's how ionic bonds are very strong, and they have high melting and boiling point as it requires a lot of energy to overcome these forces of attraction. Well, that's all for today. This video is made by request from our subscriber to Susan here YouTube channel. If you have any other requests, please write down in the comment section in Susan here YouTube channel. If you open through Susan Hira YouTube channel, and if you have any idea, input, request, or whatever, write down that and we'll reply to you soon. Bye and see you in the next video. So today's discussion is conducted by Study with Tuition Online. We cater for all the subjects and syllabus. Please email us if you're interested to join our private one-to-one tutorial or tuition with affordable price. And don't forget to subscribe and ring the bell so you will be the first to be notified when we release our latest updates, as we keep updating our resources weekly. And share and like to anybody who might need this video, because it is absolutely free and all subscription is free. Bye bye and see you in the next video. God bless you.